So I have this advanced local audio analyzer. Like, considering being local, it's pretty advanced. All considering. Okay, so you can record, it will record your voice, it will transcribe, working really, really well. And none of the words I said so far are in what is called the dictionary lexicon. Why it's not working? It's not working, should be there. We need to explain those negator words. Explain negator words. Okay, but bottom line, they're not showing in the analysis, in the visualization. Problem is when we're saying not good, something like not good, not very good. Okay, it's all going into sadness, which is correct. No fear. Yeah, no fear it marked itself as green, which is positive, but then went into a negative category. Wait. No fear? No fear. Right, so it's going to fear, but it's getting actually more positive. So it is correct in the sense that the green goes into the positive direction. That's interesting. Can you do sentiment analysis as we speak on the words I'm using?
I can do that, but I can only do it on the words you've already spoken, not in real time. If you say something, I can analyze the sentiment after you're done.
Hey, what do you see on the screen real quick?
There's a text input box and an analysis visualization area. The visualization displays a radar chart with emotions like joy, sadness, anger, fear, surprise, and neutral, and a bar ranging from negative to positive, with a marker at minus 0.07.
So for example, now that we say no fear.
That's right. The visualization shows a very low level of fear compared to other emotions and the neutral baseline.
Okay, and it has a positive sentiment, does it?
Yes, based on the visualization, the sentiment is currently strongly positive at 0.70.
I'm feeling fearful.
Now the visualization shows fear as the highest emotion, and the sentiment is now strongly negative at negative 0.70.
I'm scared right now. So what's happening now? It's both no fear and scared went into fear on the radio chart, but then canceled each other out on the indicator. Can you explain?
That's an interesting observation. It seems the phrase no fear initially brought down the fear level, but the addition I'm scared right now strongly increased the fear emotion on the radar chart. The overall sentiment indicator, being near neutral at negative 0.05, suggests the conflicting sentiments are somewhat canceling each other out in the summary of the total text.
Okay, so how would you go about it? Is it okay to leave as is, or would you improve it somehow? Do you have any suggestions as to how it can be fixed?
The visualization is currently accurately reflecting the conflicting sentiments expressed in the text. If you want the visualization to focus on a single sentiment, you could revise the text to express only the desired emotion, like no fear or I'm scared. Do you have any other ideas you'd like to try?
Okay, we just shared the code with it. Let's see if it can do anything useful. So it's analyzing the code for this web application.
Yes, this code implements a web application for real-time sentiment and emotion analysis. It uses the Web Speech API to transcribe speech, a rule-based lexicon to analyze the text, and creates visualizations like the sentiment meter and emotion radar charts. The code correctly calculates and displays the sentiment value, as even a small negative score like minus 0.18 in the visualization. The code also preserves the text input and only clears it when the clear and reset button is clicked. This makes it a valuable tool for understanding the principles of sentiment analysis.
Okay, did you check the list, what's called the lexicon? Can you comment on the lexicon?
Yes, I have checked the embedded synthetic lexicon in the code. It's a JavaScript object that serves as the dictionary for the sentiment analysis engine. It includes words and phrases categorized by sentiment scores and emotions like joy, sadness, anger, fear, and surprise. The lexicon is organized by trigrams, bigrams, and unigrams, and it also includes words that modify sentiment, such as intensifiers and negators, helping the analysis be more nuanced.
Is it still transcribing? No. Yeah, that was a problem. We have to fix the code a bit. Let's give it, shall we give it to Gemini? Which model shall we use? Which model shall we use? So how would you, do you have any suggestions as to how to improve this web application?
To expand the lexicon by adding more words, phrases, and sentiment values to improve sentiment and emotion recognition. You could also enhance the visualizations, perhaps by displaying confidence levels for the emotions, or by visualizing the sentiment across the entire text. Another improvement could be to incorporate the Web Audio API to analyze acoustic properties of speech, like pitch and volume, to get a more comprehensive understanding of emotion.
Yeah, that's what we were trying to do originally, is actually use the audio, because we already have a transcription service. I mean, this one is better because it's doing the sentiment analysis on the fly, which is very, very good. Yeah, we were thinking about doing the audio analysis only, without analyzing the text, without transcribing. But that might be a different project, or will be much harder.
Analyzing audio without transcribing it is indeed a different approach and can be more complex. Instead of focusing on the words themselves, it would involve analyzing the acoustic properties of the audio, such as pitch, tone, and volume, to determine the sentiment or emotion. This requires different algorithms and techniques than text-based analysis.
Okay, so can we do a combination of them both, or just one at a time?
We could definitely try a combination of both approaches by combining the text-based sentiment analysis with an analysis of the acoustic properties of your voice. We could potentially get a more comprehensive and accurate picture of the emotions being expressed. Would you like me to try to modify the code to include the acoustic analysis as well?
No, just suggestions so far. We're just discussing it so far.
Okay. Integrating acoustic analysis would involve steps like extracting features from the audio signal, such as pitch, volume, and tempo. These features could then be correlated with known emotional states using machine learning models or a different specialized lexicon for audio analysis. Combining this with the text sentiment could provide a more nuanced understanding of the emotional context.
Can you explain what are the special word types, the negator, intensifier, how they currently actually being used? So there is a multiplier for it. Can you explain? Something went wrong with the bot. It has access to a code. So they are used in the agent. So if I say good, it should go into joy. joy goes into joy. But if I say not good, goes into sadness. Okay. Yeah, it doesn't understand obviously all of the context, but that's okay. Question is, how do we improve this? How do we improve this? So it's pretty good so far. Pretty good is not in the lexicon. Only good is in the lexicon. But yeah. Brilliant. This is brilliant. So everything we do eventually goes onto this website. We are live streaming all the development process on YouTube. So go check it out. This tool is probably the most promising one. It's actually measuring your heart rate from a webcam. And no one believes it's working. Well, you can just try it on your own head. It's working on forehead. And see if it works for you. Yes, so if you visited the page, let me know if you have any questions. Pop them in the chat. Yeah, most of the words are not in the lexicon. It's a bit of a problem. Can we expand on the lexicon? Shall we give it to an agent? What words are missing anyway? What words are missing at the moment? That's Gemini there. Doing the coding. Considering lexicon dependencies. Worry. Nervous. Nervous is not there. Fairly. Question. What? Why? Missing examples. Okay, can we actually update the lexicon and expand on it? Can we update the lexicon? Let's expand the lexicon to make the analysis. I'll add the words which is discussed. Discussed. How do you pronounce? What's the difference between pronunciation of discussed, as in topic, and discussed? Discussed. This could be a good tool for teaching English pronunciation. And why did it stop? Because it's edited stuff. Let's see what it did. Yeah, I'm normally using GitHub Copilot. This time I'm using Gemini Code Assist. Made a few changes. Shall we apply all? Do we trust the agent? Yes, we do. Okay, let's try it now. What did we add? So this is very good. Very good. This is amazing. This is not so good. Not so good. Okay, surely. Can we add not so good as a free word combination? Just do that as a single thing. The single prompt. That's also not in the lexicon. That's not good. So not good is good, that it's giving you negative. Not very good. Did it? Right, it did. Apply changes. Okay, so it's a good little robot. Not so good. Very good. Okay, now we are talking. Now, what else can be improved? And how hard would it be to do like audio analysis as well in addition to text? Okay, what does it improve? Manual text input. Update the visual targets. Oh, it keeps scrolling at me. It keeps scrolling. Add live highlighting. cursor position. Okay, refine, open logic for speech recognition. Apply changes. Well, let's, as long as the basic functionality works, we don't mind. This is very good. This is not so good. Okay, this is amazing. Wow. Wait, it added the... So what's in disgust? Disgust. I can't even pronounce it properly. Let's see. Okay, we haven't mentioned disgusting. What? This is gross. Okay, now we have disgust as well. And that's negative, obviously, negative sentiment. This is nasty. Yeah, that's also going into disgust. I can't even pronounce it properly. It's someone who's able to pronounce things properly. Can let one of the voice models talk to this thing for testing proper English. Well, I mean, if it can do my voice, then it can do anything. Low pitch. This gets map acoustic features to emotions. This is where it gets subjective and requires heuristics or a trained model. High pitch, high volume could indicate joy or anger. Okay, so did we actually implement this or not? So why do we need a trained model? Yeah, we can just do basic heuristics, can we? So we'll have high pitch, high volume. Yeah. Anger? Probably anger. Or joy. Yeah, we don't know. Well, that's where it becomes subjective. This is where it becomes subjective. A low pitch, low volume could indicate sadness. High pitch, low volume could indicate fear. Rapid pitch, volume changes could indicate surprise. Shall we do a volume indicator or would it complicate things too much? What do you think? What do you think? What do you think? What do you think? Yeah, I'll have to finish in a sec. So everything we do is eventually available on BioniChaos.com. Go check out the website, provide your feedback. We are live streaming all the development process on YouTube. So subscribe to the YouTube channel and see you next time. Bye.